Welcome to Academic Guru's Tutoring Thursday, where we answer all of your high school, college, and university questions. If you would like your question to be featured on next week's Tutoring Thursday, please submit your questions to questions@academicgurusinc.com. Don't forget to subscribe so you can stay current with all of our new videos. Today I'll be solving a physics question involving the electric circuit, and the question reads, a current of 0.2 amps flows through a wire whose ends are at a potential difference of 15 volts. A, find the resistance, and B, find the heat produced in 1 minute. I think the easiest way to start off any physics word problem is to start off with the clues that you've been given. So in other words, what we know from the problem is that we have a current of 0.2 amps and a potential difference of 15 volts. The duration of time of interest is 1 minute, and we've been given the task of identifying the resistance of the electric circuit and the heat released, which is just the energy transferred. Now that we understand the clues that we've been given and the parts of the question that we are asked to find, the next step is to identify the appropriate physics equation that will allow us to find the resistance and the heat released. Let's start off with part A, which asks us to determine the resistance of the electric circuit. If you've studied your physics equations and concepts well, you should be able to identify Ohm's law as the ideal equation that describes the relationship between current, potential difference, and resistance. Ohm's law tells us that the potential difference is directly proportional to the current of the electric circle, where V is the potential difference, I the current, and R resistance of the electric current. Now our task is to find resistance, not potential difference. In order to isolate the resistance term, we have to divide both sides of the Ohm's law equation by the current. And here we can easily see that we can cancel out the currents in the numerator and denominator of the right side of the equation. After canceling out the terms, we find that the resistance is equal to the potential difference divided by current. After plugging in the respective values, we find that the resistance is equal to 75 ohms. Now we can move on to part B of the question. Part B of the question asks us to find the heat produced in 1 minute. The key here is to use the clues given, so our current, our potential difference, duration of time, and resistance, to identify a relationship that allows us to determine or calculate the heat or energy released. Again, this part of the question is a little bit trickier, but it requires that you really understand the concepts of electric circuits, heat release, potential difference, and the current. And what you'll recognize is that the missing part of this equation is the concept of the charge. Charge is really the product of current multiplied by time. But charge alone doesn't allow us to calculate the heat released from the electric circuit. Heat released, or energy transfer, is actually what we're looking for. Heat released is the product of our charge multiplied by our potential difference. Now that we understand these two relationships, we can substitute our charge with current multiplied by time, and then multiply that by our potential difference. Once we plug in all of the respective values and calculate that through, we find that the heat released within the electric circuit is equal to 180 joules. So there you are. I hope you found this helpful. Thank you for tuning into our Tutoring Thursday channel. If you enjoyed watching this video and found it helpful, please give us a thumbs up, comment, and subscribe. We would love to hear from you. Until next week's Tutoring Thursday, happy studying.